Hi everyone, in this video we're going to go over another Leetcode question, part sum 2. Major tech companies like Google, Facebook, Microsoft, LinkedIn are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Given a binary tree and a sum, find all root to leaf paths where each path's sum equals the given sum. Note, a leaf is a node with no children. Example, given the below binary tree and sum 22, find the paths for this tree. So we are given a binary tree and a sum, in this case 22. We need to find all root to leaf paths that add up to given sum 22. For example, in this case 5, 4, 11, 2 is 22, 5, 8, 4, 5 is 22 again. And we return a list of lists in the result. That's all we need to do. So I recorded path sum 1 video as well. If you watch that video and come back to this one, that may be helpful. Then you may understand better. But I will try to explain here anyway. Let's get on the whiteboard and try to solve this question. So we are given a binary tree. We need to create a DFS function for this one. This is a helper function, recursive function, that will go traverse left and right subtrees until it finds the answer. So this is the function given by the question. In this function, we create collect sum, or let's call it DFS is easier for this. DFS function. This is the helper function and recursive. We send the root value first, that is 5. New array list integer, we are sending a list to this. This is where we kick off everything. We send the list here to the question and send the sum integer value that is coming from the question. So in this case it's 22. Sorry about my writing. 22 here. Let's write it better. So we are sending 22 here. And finally, after this DFS is done, we are returning the result. Result is the array list that we created separately, list of lists that we create separately, and we will fill this list in this DFS call. So 3 separate entities. Result is here, then we send this result. Sorry, we fill this result in the DFS call, and we return, after DFS is complete, we return this result. That's all we need to do. So let's see this DFS. This DFS has 3 parameters. One of them is node. So we go through all the nodes here. We can call it node or root. For this one, I call it root. As we go through, we need a list of the items so far. So 5, 4. We send this list every time we call this. And the total integer sum. Every time we pass a node, we deduct the value of that node in the next sum parameter. For example, we started with 22. For this one, we send 17. We deduct 5, subtract 5, and send 17 to 4. Subtract current value 4 and send next call 13 to this one. Subtract 11, send 2 to this one. Then make the right call and send 2 to this one. And finally we reach 22 here. In the DFS call, the very first thing we do is check if root is null. If current item is null, then we will return. DFS is broken. Done. Otherwise, we continue. We add current value to our list. So this value is added to the list. So subtract that from the total value, 22. Then check, are we at the leaf node? To check if we are at the leaf node, check root.left is equal to null, root.right is equal to null. This is leaf node check. And sum minus root.value, in this case 22 minus 5, is it equal to 0? No. Then do not add this to the list. We are not adding here. Continue. Then we continue with left call, root.left. Excuse me. We're traversing left tree. Each time we send a new array list, new list, a copy of the list we've got. We have a list here, and we send a copy of the list to the parameter again. Like we are making this call and sending a copy of the list here. And as the sum value, first we send 22. When we subtract 5, this time we send 17. Sum minus root.value. And keep calling, next time 13, next time 2. And here we check sum minus root.value is equal to 0. Because sum is each time we subtract, and sum is a new value each time we send, and that should be equal to the root.value. So finally, that should be equal to the leaf value actually. Leaf.value should be equal to the sum, the very final sum coming from this one. So in that case, we add this list that we created along the way to the first list of lists we created. Then we do the same for the right subtree, and go through. Then we create a path here. Add this list to the list of lists again. So we are traversing left and we are traversing right for this node. And we are doing this for every node. For every node, we have actually 4 steps. We are adding the node value. We are checking if it's the leaf node. If not, we do the left recursion, we do the right recursion. Left subtree call, right subtree call. And each time we subtract the root's value from the sum, and we send a copy of the list. Just pay attention here. It's not the list, but a copy of the list. And this way, we traverse all the tree, and finally, we return here. When this DFS is done, we return the result here. That's all we need to do. This is the main function, and we return the result in the main function after the DFS call. And the result is actually created, we create separately. We call the DFS, we fill the result list, and return the result here. That's all we need to do. Let's see this in the code. Separate result list, the kickoff here, sending new array list beginning, sending the total sum 22. If root is null, return, then break the recursion. Each time add to the list the root.value, node value. Check if it's the leaf node, if that's the case, and if we reach 0, add it to the list. Then keep recursion, doing the recursion, and finalize the call. Let's submit and see. Okay, this works for this question. I hope this makes sense to you guys. I try to explain as much as I can. It would be a good idea if you watch path sum 1 before watching this one. Again, after this one, and come back to this video again. And then you may understand things better. Thanks for watching. I have more videos coming up. So If you subscribe to my channel, we can meet again later. Thanks for watching again. Goodbye.